Hello my PU2 warriors, welcome to the session number 1, the lesson number 1 of mathematics in the Brahmastra 2.0 our PU2 prep for 2026 examination. Okay, so we all know the importance of PU2, right? I don't have to tell you about that. It's very important because for all the KCET aspirants, PU2 carries half the weightage, right? So we have to arm ourselves with the best possible way to get the maximum output, the maximum marks in the PU2 examination. Okay, 290, 295 plus should be there in the PCM. That is the goal. And why it is easy also, because PU2 syllabus is relatively easier to what is there in KCET. So we can get, why to lose any marks over here basically? We can get the maximum number of marks in this particular examination, so that will help us get a better rank in KCET. Okay, so not only your boards examination, KCET also has some soft part, your basically advantage in the case of PU2. Okay, so for that we have brought the Brahmastra, and I'm here, your Ankit Sir, to take care of mathematics end. Okay, now don't worry, everything that you need to understand, to learn in mathematics for PU2 will be delivered by me on our platform Deeksha Karnataka. So if you are watching this session for the first time, if you're watching me for the first time on this platform, do subscribe the channel right now, subscribe right away, okay, so that you don't miss out on any of the lectures, because yes, we have few months left, and from here onwards we have to very much careful, very much planned in our work. And let me do all the planning for all of you. Just you come, attend the lecture, follow my words, follow my strategy. I will do the planning for you, I'll do all the work, you just follow my work, okay, and you'll be very good, very much prepared for your PU2 examination. Is that okay for all of you? Are you in it to get 95% marks in your PCM? If you are, do let me know in the comment section. I understand this is a recorded video, okay, but do not worry about that. When this video will be given to all of you, when it will be premiered to all of you, I'll be available watching and reading your comments. So do let me know if you are ready for that 95% marks in PU2. Okay, so don't worry, everything will be covered by me in the mathematics. Whether it is MCQ, sir, somebody says I have MCQ as the problem, sir. Somebody says, sir, I have the big questions of integration as the problem, sir. Everything will be dealt over here. Your 1 marker, 2 marker, 3 marker, 5 marker, 6 marker, 4 marker, everything I'll take care of. Will make you practice so much that you won't have the fear of even losing 2 marks, 5 marks or 10 marks in your any of the sections. So just believe me, trust on my words, and start working from today, and you will be very much surprised the progress that you're making, and very much satisfied with the result that you'll get after examination. So let's start the session. Okay, first thing is the important chapter. Sir, why relation and function? We could have started with continuity. Why would we start with continuity? This is very important. This carries 9 marks. How can I say that? Let me show you. 1 second. So see over here in the blueprint side, if you see the blueprint, how many marks of questions are coming, sir? Check here. 1 mark from MCQ, 1 is a 3 marker, 1 is a 5 marker. Add them. 5 plus 3 plus 1. 5 plus 3 plus 1 is how much? It's going to be 8 marks. Sorry, 9 marks, right? 1 plus 3 plus 5. Total is what? 9 marks over here. Then, sir, it is an optional row. I can choose to release it or not do it. Why would you do that? If you solve this easy chapter and you get 9 marks, why won't you select these 9 marks? Okay, so basically this is very important. Okay, 9 marks from the chapter, the first chapter, relation and function only. So do not skip it, do not take it lightly. Okay, so same way I'll give the analysis for every particular chapter, how many questions are coming, why to do it, what type of questions to do it. Okay, because we are aiming for 90-95 plus marks in our mathematics, and I'm going to make that happen for you. Just trust on me, keep working hard with me. If you do that, that's it. Okay, so this is your blueprint. I hope this is clear. 1 3 5, total is 9. I already written over there. Total 3 questions will come. Yes, there will be options. In the other category, MCQ is a mandatory section. It's a compulsory section, so that has to be done from all of you. I hope the clarity is there for the blueprint side. Okay, again, this is as per your 2026 examination by your board. Okay, next, what is next, sir? So in the session today, what I have brought for all of you, how are we going to conquer this particular chapter, relation and function? What are the the ingredients of this particular session is? Start from here, the revision. Yes, the concept which is there for your syllabus, I'm gonna revise that as well. So first will be your revision. Later on, next comes your question practice. What questions the category was? 1 marker, 3 marker, 5 marker. Check here. MCQ, SA3 and LA5. Short answer 3 marker, long answer 5 marker. So I've taken questions like this only. Total I have taken 24 questions actually, but I'm going to solve 23 only. Check here. 12 plus this and this, if you add them, will become 24. But I'm going to solve only till question number 23 because I'm going to give you homework as well. Even it's one question but carries 5 marks. I want to know how many of you are actually attempting that question and how many of you are actually interested in getting that 95% marks in maths. Okay, so I'll give you one question as homework today. So do wait till that end and solve that question as well from your side. So I'm going to discuss total of 23 questions from my side, one question as homework. Next, I'll also let you know the most important topics of this particular chapter, relation and function. Okay, so for this chapter actually not much is there. We have only the definitions of reflexive, symmetric and transitive. Then we move on to 1 and on to functions. But still, for other chapters to come, I'll let you know from where you can expect the questions. That's why most important topics. Okay, so let's move on to the session itself now. I hope this is very much clear, starting with your first thing, which is revision. Okay, let's start. So complete revision of the concepts. First thing is, so there are more than these 3 definitions, but this is about exam point of view. So if you understand only exam point of view, these are the 3 which is very, very important: reflexive, symmetric and transitive relation. Check here. If you have any, again, to write a relation you need what? You need something that is called a set. So let's say I have a set A. I have a set A defined like this: 1, 2 and 3. 1, 2 and 3. I have taken a set for a reason that I'm going to give you examples also. Okay, sir. All right, sir. Accepted. Check here. For the set 1, 2, 3 are the elements in the set. If I have to define a reflexive relation in the set A or on the set A, I have to consider what? An ordered pair. Relation will always have an ordered pair. Okay, so let's say the ordered pair is A comma A. In case of reflexive, it becomes A R A. The ordered pair is what? A comma A. If you have, for every element, listen to me, for every element in the given set A, if you have the A comma A ordered pair present, then what will happen? Then that relation can be called as reflexive relation. For example, for the set A, for this set A, the relation R1 will be reflexive only if it has 1 comma 1, 2 comma 2 and 3 comma 3 and 3 comma 3. If even one of them are missing, it will be no longer reflexive relation. Okay, so sir, isn't this same as identity relation? Yes, it is. So far, this is same as identity relation. Then you might have a question. So then what is the difference between reflexive and identity? Are they the same thing? No, they are not the same thing. Identity is what I've written over here on the screen. Reflexive has a definition that apart from these three has to be there. We can also have other ordered pairs. I can have 1, 2, 2, 3. I hope this is clear. Okay. Let's understand reflexive properly. AA should be present for any set given like this. Moving on to symmetric now. Okay, so with reflexive clear, let's understand symmetric. Very simple. So in this we had a case of every single element in the given set where you're defining the relation R1 on A. Okay, in this case you'll not have a case of all the elements. Whatever element follows the ordered pair AB. Okay, so this will mean ordered pair AB. ARB means ordered pair AB. Then if this is the if condition, this is my if condition, means for the relation R1, if AB is present, I should also have BRA present. So ordered pair should be B comma A. So example, if I have to take, check here. So if I write a relation R1, if I have 1, 2 present over here, and I want to call this relation to be symmetric, I must have even 2, 1 the ordered pair also present. So 1, 2 ordered pair is present, so as 2, 1 also should be present in the case of the symmetric relation. Are the first two clear? Moving on to the next one, which is transitive relation. This is important and this is where student gets stuck on it. Now, before I move on to transitive, I want to say one statement. So whenever you have a question in examination on this property, do not look for the values of x or whatever is ABC, the ordered pair, where these relations are symmetric or transitive or reflexive. Look for those values where it is not reflexive, not transitive and not symmetric, because even if you can find one such ordered pair, then the given statement or given functions or relation can never be that particular type. I'll repeat myself. Try to look for those examples, those values where the given relation is not transitive, not symmetric, not reflexive. It's easier to identify that way. Okay, clear? Let's move on then. Yeah, so for transitive relation now, what is the condition? We have two if statement over here. So you'll have two if statements, which is ARB, means the ordered pair is A comma B. Next is what? BRC, the ordered pair is B comma C. These two are both if statements. Then statement comes over here as ARC. So what it means is basically, if in a relation I have AB, for example, relation R1 has AB means 1, 2, and I have, let's say, 2, 3. I have 1, 2 and 2, 3. Then for the given relation R1 to be transitive, I must have 1, 3 also. Check here, AB, BC, then AC should also be there. If there is 1, 2, if there is 2, 3, then I also should have 1, 3 as well. Okay. Now I want to say one more thing over here about all of these. So one second, especially about transitive relation, whenever you have this combination, okay, whenever you have AA combination and BB, if you have in a relation ABB and they're asking you to check whether if you add AB, will it be transitive or not? Always. If ABB and AB is there, always transitive, never check for it. If AB is there, never check for transitivity, it will be always transitive. Okay. Other condition, if you have ABB and you're looking for, let's say, BA. This is AB, this is BA. If they're saying this combination, ABB, BA, even that will be always transitive. So whatever, if you have the, that identical wala ordered pair available and you're looking for AB and BA, don't check, it will be always transitive. So if you have ABB, then AB will be always making a transitive relation. Okay, let's move on. I hope this is clear. So that's what I'm going to do for your relations part. This is the end of your relation. I will not drag it anymore. Okay, so concept, I've explained everything with the help of these three classifications only. I hope this makes sense. Let's move on to next part. Next part is functions. This is another name for functions. Do you all know it? It's also called as mappings. It's also called as mappings. Okay, so function definition I'm not going to write, is there in your NCERT. Do check it. So but I'll tell you. Okay, what is it? It always involves two sets over here. The set will be from, let's say it can be A to A, but we'll write two different sets. Let's say defined from A to B. Okay, this set A is called as domain. This set A is called as domain, and this set B is called as codomain. It's called as codomain. Okay, sir, that much is clear, sir. This is domain, this is codomain. What next? The next thing is, for every element in the set A, listen to me, for every element in the set A, there should be a unique element in the set B. Okay, for example, I said mapping, right? Let's do a mapping. This is my set A per se, and this is my set B. I've written the domain and codomain. So if I have, let's say, elements 1, 2, 3 and 5. Here I have, let's say I have A, F, E, T, A, F, E, T. Okay, this is 5 I've written. So what I meant when I said that for every element in set A, there should be unique, means for one element, it cannot go to two options. Means the same element will not be mapped to two different elements in the codomain. If there's a mapping like this, it will not be a function. Listen to me, if there is a mapping like this, it will be not a function. Okay, so basically for one x, there will be no two values of y. But the opposite is true. Check here. If I write like this, if I write like this. What about this, sir? Yes, it is true. For one x, I have one value of y. For another x, I have a different value of y. Basically, that is same. But for one value of x, for one element in the domain, I don't have two different values because it's going to be unique. So one a is also a. So a is uniquely with 1 and 2 related. Okay. So this kind of relation is called as function. Clear? Let's move on. Now let me tell you, we can understand the same mapping with the help of example also. Basically example of graph also. Okay, so if I draw a graph like this, for example this over here, for one value of y, for one value of y, I have two different value of x. For one value of y, I have two different value of x. Means if I take this y value to be 1, I can have here -1, and here I can have +1. So either x is -1 or +1. It's both leading to what? It's both leading to 1 only. So this will be a function. But if I take this case, then for one value of x, I have two different value of y. This will be not a function anymore. Okay. So basically, how to test whether a given relation is a function? Just simply, if you can draw the graph of it, draw the graph and check whether it's able to satisfy the vertical test or not. What is the vertical line test? If you draw a straight line, you should have only one intersection. For example, for this graph, you check. For this graph, if I draw at any point a straight line, I'll have a unique intersection. Okay. So basically, this is going to be a case of functions. If I write here, function, yes sir. Function, no sir. Getting my point? So this is the understanding with the help of graph. What is the meaning of mapping? What is a function? Function is when every element in the domain should be uniquely related to a value or an element in the codomain. Mapping part is clear. The test part of vertical line test is also clear. How to understand two type of cases when you have for one y two different value of x, and for one x we have two different value of y. Why this is not a function and why this is a function. So basics of the function is clear. Now we'll move on to the range. We have still not discussed the range, and then we'll go to one onto functions as well. So what is range now? What is range now? Let me try to write it for you. Over here you check. 3 is going to E, let's say, and F5 is going to T. So if you see this mapping over here, I can write an ordered pair, right? I can write an ordered pair. Let me erase these things. Okay, I don't need to erase, I'll just use it, this space, okay? I'll just use this space. Write the ordered pairs. 1, A, sir. 2, also A. 3, E, and 5, T. This is my ordered pair. This is my ordered pair after the mapping. So the y coordinate of the ordered pair, if you check, will be having A and then E and then T. There is no repetition, only AET is there. Only AET is there. Don't write A, E, T. Only write AET. Now this value here is called as range. This value here is called as range. Okay, check this carefully. First write the, after mapping is done, write the ordered pair. Not always you have to draw the mapping, okay, just to understand the concept that I'm telling you over here. After the ordered pair is done, after the mapping is done, write the ordered pair and check the y coordinate. That will be your range. Now check carefully. Range is not always equal to the codomain. What is the codomain over here? AFET. What's the range over here? AET. So are the range and codomain equal? No. So indirectly I've told you that whenever you have, I'll tell you an example, whenever you have that codomain and range not equal, that is basically onto function. We'll get to that, no problem, but right now just understand this. This B represents codomain and this represents your domain, written over here only. This is your domain. I hope this is clear now. I hope things are getting clearer. So I'll tell you what is my expectation from this slide. You should know what is function. Function is a mapping from element of domain to codomain. It should be unique mapping. Unique mapping 1 to A and 2 to A. They are unique in nature. For 1, I don't have two different values in Y. Okay. Vertical line test I have done for different type of functions. If you draw a vertical line, I should get only one intersection in the graph. That's vertical line test. Here it is disapproved. So that's why this is not a function. This is a function. Okay. Mapping part is clear. Now what is range? Only the y coordinate of your ordered pair is called as range. So this is what my expectation from this particular side is. Next we're going to move on to 1 and onto function. I hope this made sense to you. Moving on. Now it's time to learn the types of functions that we have to deal with and from where the questions will come. So we have 4 categories. We have one function, okay. Then we have, of course, many one function, okay. Then we have onto, and the last is into. The last is into. Understand this very clearly. One and many one are just opposite to each other. What's the meaning of one function? So this is where every value of x will relate to only one value in y. So I showed you mapping now over here like this, that from this value I was going to 2 different values, okay. Sorry, this is not even a function, right? This is not even a function, okay. I showed that I had 2 different value of x going to the same value of y. Is this a function? Yes. Is this a one function? No. For one function, what will happen? You'll have for every distinct value of x, distinct element of domain will have distinct image. The mapping, what you get after mapping is called as image in codomain. Okay, check here. So if I write an order pair A comma B, let's say A comma B, so this B is called as the image of the point A. B is called as image of the point A, okay. So distinct element of the domain will have distinct image in the codomain or your the set B, okay. So basically the mapping will become like this. So if this is, let's say, A, this will be B. If let's say this is 1, this will be, let's say, something like K and so on, whatever it is, the mapping will be like this, always unique in nature. This is the case of one function, okay. This is the case of one function. What about many one? Many one will be just opposite. This will be just opposite. For this, the mapping will be many to 1. Check here. So I have, let's say, 1, 2, and this is A. So both of these are mapped to the same element A. Same element A, okay. Now onto function. Onto function is again, I'm going to explain you everything with the help of mapping. Then I'll teach you how to identify this using 2 approaches, algebraic as well as graphical, okay. Now onto function, check here with the mapping. So this here works with something called as range and codomain. Whenever you have range and codomain equal, that type of function is called as onto function, okay. We have 1, 2, 3, and we have EF, let's say K, EFK, 1 to E and EFK, 1 to E, F2 2, and this is mapped, okay. Check the ordered pair here. We have 1 comma E. If I write here directly, okay, let me write 1, 2 comma F and 3 comma K. What is my range? My range directly is over here as EFK. EFK is my range actually. What is the codomain? Codomain is also EFK. The set B is called as codomain, no? This itself is called as codomain. This is my set A and this is set B. Set B is codomain. Check here. EFK means the range is equal to codomain. The range is equal to codomain, that becomes onto function. If I write into, it will be just opposite. Let's say if I have EFK, I have also O. 1, 2, 3. So E, like this mapped, but we have one element O left out, okay. So your codomain is what? EFKO, and your range is what? EFK. Not equal. When the codomain and range are not equal, it is called as what is it? It's called as into function. So I hope it is clear. One, many one, onto, into. Okay, one, many one is opposite to each other. Again, onto, into are opposite to each other. Okay, let's move on to the finding algebraic and graphical approach. Okay, so what is the discussion now? We're going to discuss how to identify a given function to be one or onto. Let's start with the first one, which is fx is one function. Fx is one function. 2 ways. One of the ways, the most important one, the algebraic method. Other is the graphical approach. Useful in some questions but not all. Okay, so let's start with the method number 1, which is going to be your algebraic approach. Okay, sir. Algebraic method. works. Clear? Now what you do in this, you check for the condition that if f of x1 and f of x2 means the function value at two different points are equal. The function value at two different points are equal, then always x1 will be equal to x2. Then always x1 will be equal to x2. So you try from here, and if you get this actually the case, then you will say the given function is 1 1. Other way also is there, okay? Other way is there that if you have x1 not equal to x2, means the two different values, basically x1 and x2 are not equal. They are the different values, okay? Then f of x1 must not be equal to f of x2. This is the algebraic method. Is that it, sir? Yes, is that it? Sir, I did not get this, what you're telling me over here. Some of you might feel that way. It's okay, don't worry. I have taken so many questions, but I'm going to discuss this method one by one. Okay, so works. So whenever you have, there are two situations. Whenever you have f of x1 equals to f of x2, you say that x1 must be equal to x2. And when you obtain this condition, you'll say that the given function is 1 1 function. Okay, now the method 1 is over. Method 2, my personal favorite, graphical approach or graphical method. Method 2 is the graphical method. Okay sir, how to deal with this? Very simple. Do remember when I explained you the function definition, I said do a vertical line test. If you get two intersections, that's going to be not a function. The given relation will not be a function in that particular case. In this case, you're gonna do what? You're gonna do a horizontal line test. Okay, check here. I'll take example. My favorite example, modulus function. Another favorite example, a constant function y equal to 2. Okay. Another example, okay, let's take a linear function now. Few more examples we'll take to understand this better. Okay, I'll take few more examples. What happened? Okay, it's here. Example number 1, example number 2, example number 3, and example number 4. Example 3 would be y equal to x cube, let's say. Or we can go with sine function. Let's take sine function, but only in this domain. What is this domain called as? Minus pi by 2 to pi by 2. Okay, minus pi by 2 to pi by 2. This is a sine function. I hope you know that. Usually what happens if you take y equal to sine x, I can take, what is the domain of y equal to sine x? What is the domain of y equal to sine x? Let me know in the comment section right now. I am watching your comments. What is it? All real numbers. Yes. But if I have given the restriction that it is from only minus pi by 2 to pi by 2, then we'll see the case. Okay, I've taken that example. And the last one, our all favorite parabola. Okay, parabola. 4 cases. What did I say? Do a horizontal line test. Do a horizontal line test. What do we do in that? Simply draw a straight line parallel to x-axis. Anywhere. Here, sir. But it should, touching the curve. Actually, cannot go like and draw it here. If you draw it here, sir, no intersection. No, you have to make sure that there's an intersection with the curve. Okay. Over here, you have to go and draw on the line. Okay. If over here, anywhere you draw, here or up also, you draw it over here. Okay. Now check carefully. Whenever you have only one point of intersection, whenever you have one point of intersection, whenever you have only one point of intersection, then that given function will be 1 1. Here, is it 1 1, sir? No. So right here, not 1 1 means many 1. Opposite of 1 1 is many 1. So not 1 1 means many 1. Is it 1 1, sir? No. There is infinite number of intersections, sir. There is infinite number of intersection. Every point is a intersection. Again, many 1. Again, many 1. What about this one? Sir, only one intersection. So this will be your 1 1. How about this? Sir, 2 point of intersection. This will be your, again, many 1. Please check. Now, there are different ways to make even these two functions 1 1. How do we do it? I know few of you might also already know. If you change the domain, if I say, what is the domain of this function right now? All real. If I make only positive value from here to here, then it will become 1, 1. For example, same condition, if I make only for positive value, it will become 1, 1. So I hope the graphical part as well as the algebraic part is clear for 1, 1 function. Let's move on to now. Okay, now we are dealing with onto function. First thing is very important, algebraic method. Now graphical method over here will vary with respect to your question to question. You have to check the domain and codomain, all of that. Okay, but for onto function, the mapping is important and the algebraic method is important. And what is that? So method 1 or only important method will be algebraic method. Okay, so what you do in this? Simply you find the range and put it equal to codomain. If it is there, means it'll be onto. That's it. Okay, and other way to understand this will be using mappings. If this is your codomain and this is your domain, okay, and you have elements over here, 1, 2, 3. Okay, then this will be this is left out, right? So not onto. Okay, getting it? Let's move on then. Okay, the last is concept will be inverse of a function. So when can you say invertible function are there? When can you say given function is invertible? If a given function fx for any domain to codomain, of course, set A to B you can write. If in this set A to B, if the given function is both 1, 1 and also onto. So if the given function is both 1 and onto, then it becomes called as bijective. Then it becomes basically, there's a given name for it, bijective. Okay, individually this is called as injective and this is called as surjective. This is called as surjective. So basically, if a given function is injective and surjective both, it's called as bijective. And if a function is bijective, you can simply say the given function fx will be invertible. Now it's time to solve some questions. Let's start. So the concepts are clear. We are moving on to the solving of the 23 questions that we have taken, starting from the MCQ. First one, the relation R in the set 1, 2, 3 given by R1, 2, 2, 1 is what? Simply symmetric. It's going to be symmetric only, right? So here's the answer, option B, symmetric. Yeah, 1 to 2, 1 is there. It's a PYQ also from your board. So it's 1 to 2, 1 means it's going to be only symmetric. Okay. Moving on, question number 2. Both the empty relation and universal relation is what? They are both trivial relation. It's a definition based questions. You have to know all these definitions. Where you will find these definitions? I have not discussed them. They're very simple. You can simply go ahead and check your summary of NCERT. You'll find everything for this chapter. Okay, the definition part. 2C. Next, 3. A relation R in a set A if each element of A is related to every element of A. Each element of A related to every element of A. Simply definition of universal relation. Definition of universal relation. Yes? Clear, right? Yeah. Question number 4. Let R be the relation in set N given by, okay, so basically B should be more than 6. So we have these 3 options here, 8, 8, 7, and difference of A and B should be 2. Correct, na? If I move A on this side, I'll get 2 equals to B minus A. Difference of B and A should be 2. Only possible in the option C. So option is C. Be logical in the approach, okay? Be logical. You don't have to solve it, right? Simply logic will get you the answer quicker. Fifth one. Consider the non-empty set consisting of a children in a family and relation R defined as, okay? So your ARB represents A is brother of B. Okay. So if I say A is brother of B, will B be a brother of A? Not necessary, right? Because B can be a sister as well, right? So B can be a girl child, A can be a boy child. So A is a brother of B, correct. if we have this person A as boy and B as girl, then A is a brother of B, correct, okay, but B is a brother of A, no, B can be sister as well, so not symmetric. Symmetric, no, okay. Let's select for transitive now. So transitive will be two cases. This is dealt with. We'll have A, B and C. So A is a brother of B means it has to be a boy child, because it has to be given, right? These are the if statement. AB is give statement. A is a brother of B means A has to be a boy, a male child. If B is a brother of C means even B has to be a boy. C can be either boy or can be a girl also. Can be a girl also. The transitive relation says that if ARB is true, BRC is true, ARC should also be true. From here you write ARC. Basically AC. A was boy. Let's take this case to be of girl only. Even that case is there. A is a brother of C. That's true. Okay. So it will be only transitive, not symmetric. Option B is true. So transitive, yes. Symmetric, no. Clarity is there. Logic we're gonna use and get the question done very quickly. Question number 6. If n function defined from where to where? Now from here onwards, no. Whenever you have bijection 1, 1 onto function defined, please be careful with the domain and codomain. Here it is natural number set. Now what are they saying? Y equal to x square. Y equal to x square is the function. Check for 1, 1 onto. Okay. What is the way to check for 1, 1? Check here. x1 square equals to x2 square. So x1 will be equal to plus minus x2. As I said, if I take f of x1 equal to f of x2, I should get only one value. But I'm getting two different values. So not possible. So not 1, 1. What about onto? Check here. X is root of y, right? Yes. So sorry, I'm having a little cold, so got a cough. Okay, let's continue. Let's continue now. X equals to root of y. What are you gonna get? What are you gonna get? Check. So from here, y is a natural number, right? Y is a natural number. So if you take a natural number like this, what will be this? I can take y value as, let's say, 3. So this answer can never be a natural number. Root 3 is 1.732, which is a real number but not a natural number. So for example, my point is, if I check here the mapping, so this is natural number means 1, 2, 3, 4 and so on, and over here also I'll have 1, 2, 3 and 4 so on. Okay, but this 3 will not be mapped. This will be left out. For 1 it will be what? 1. 2 will also be left out actually. 2 will also be left out. For 2 will be 4 and so on. So you can see some of the elements of the codomain is left out. It means not onto. Not. So answer is what? Option D. Answer is option D. Okay, fair enough. Question number 7 now. Let f z to z, we have fx equals to x cube. Okay, why? How are we going to go about this? x1 cube equals to x2 cube from f of x1 equals to f of x2, and from here if you take cube root, we all know it's going to be unique, so they're equal. So means true. Correct, na? Started with what? This is nothing but f of x1 equals to f of x2, and we're getting this. If somebody is thinking why can't we have plus minus sign, it doesn't work like that. In cube root we will have unique value. Okay, so please check. In that case it's going to be fx is 1, 1. 1, 1. Now since it is an integer, okay, we'll continue for the onto part. Y equals to x cube I have, so I'll have x equals to cube root of y. So check here, if I put the value of y as 4, can you find cube root of 4? No. So this can never be equal to an integer. This will be some decimal value, right? So this will never be equal to integer. It will be a real number, rational number, but never a irrational number, but never a integer. Okay, so in this case what happens, basically the given f is not onto. So combination you check 1, 1 but not onto. Option C. Option C. Question number 8 now. Let A equals to 1, 2, 3 all the way till n, the number of surjections from A to A. Whenever you write A to A, no, whenever you write a function, whenever you write A to a function defined like this, means codomain is A as well as domain is also A. Then understand this, if the function is defined like this, okay, then if f is 1, 1, then it will also be on 2. If f is on 2, then it will always be 1, 1. That's the combination. So basically, if the function is defined on the same set as domain and codomain, if 1, 1, always be on 2, if always be 1, 1 also. Okay. So if it is surjections, so basically surjections in this case will imply number of bijections, because 1, 1 on 2 means number of bijections, and for that we have a formula as n factorial. Basically number of surjections here, no, will be equal to number of bijections in this case, which is nothing but n factorial. Answer is B. Getting my point? Yes? Okay. Moving on. Alright. This is a question from your latest question bank given by your board. So question bank 2026. Okay. Let's see the problem. The maximum number of equivalence relation on the set A, 1, 2, 3. Now if you know something called as Bell number. What is Bell number? Is the number of ways you can create a partition of a set with non-empty relations. Okay. So with non-empty, very important, the word is non-empty. So if you have 0 element, it will be 1. If you have 1 element, basically, so Bell number with 0 element of set will be 1. Bell number of a 1 element set will be, of course, 1 only. And same way, B3, in this case we have 3, it will be 5. It will be 5. So if you know B3 as 5, answer is what? Option D. Answer is option D. But for many of you who don't know Bell number concept, don't worry, I'll tell you. So for this case, no, we're looking for equivalence relation, right? So don't worry, we'll start from where? First is this only, no? 1, 2, 3. What is this 1, 2, 3 means? Basically the combination of all ones, all twos, all three. 1, 1, 2, 2, 3, 3. Okay. So basically that is there. Then we'll have combination of 1, 2 and we'll have 3 also. Basically, so combination of 3 will be 3, 3. 1, 1, 2, 2, 1, 2, 2, 1, right? 1, 1, 2, 2, 1, 2, 2, 1. Like that if you go, so you'll have a case another like this, no? You'll have same thing go with 1, 3 also. And you'll have 2, 3 also. And the last will be all, okay? The all relation. So one more will be there. Answer is 5 in that case, 1, 2, 3, 4, 5. Okay, next one. Okay, question number 10 now. Let FR2 be defined like this. Okay. Domain. Domain is all real, but not possible because function is given as 1 by x. If I take 1 by 0, it will be undefined. Right, no? Because 0 is the real number. Am I right? Yes. If I take 0, then it will be undefined. Answer is option D. Answer is option D. Next, FR2 are fx2x plus 6. They have given bijective, means they have given invertible. They have given invertible. Now we are looking for inverse. Check. Inverse will be what? Simply y equals to 2x plus 6. Right here, y minus 6 equals to 2x, and then divide by 2. Y minus 6 by 2 equals to x. So I'm getting x value as y by 2 minus 3. Now change the variable to x and y. Okay, so this x will become y and this will be x by 2 minus 3. Okay, so basically what you do in finding the inverse of a function, simply make x subject and then change the variable from x to y. Okay, you get the answer as option A. Option clear. Next question. A contains 5 elements and the B contains 6 elements. Number of onto mappings 0. This has to be either more or equal to this, not less, not less. So number of onto mapping will be 0. This has to be more, not less. Okay, so basically NA has to be more than or equal to NB. The cardinal number of the set A has to be more. Next one. Okay, now we are moving to the 3 marker category. As I said, this chapter is going to be asking the question on 1, 3 and 5 marker. That's why here it is 3 mark category. Okay, let's solve the first one. Relation R on the set A. Again, this is a question from the question bank 2026 paper as per boards. So they're given a set A, R equals to x comma y, 3x minus y is given. From here what I can write is y equal to 3x. We are checking for reflexive, symmetric and transitive. Okay, check reflexive, though I don't think it's possible. I cannot have A over here. If you take x as 1, I cannot get y as 1, right? Y will be 3. So it's not possible. Okay, if I use y equal to 3x, no, I'll use x as A, I will get y as 3a, which is not equal to a. So given relation is not reflexive. Is not reflexive. Is it clear? Okay. Next will be what? Next will be your case of symmetric. Check here. Case of symmetric. For that I can take another case. I can take x as 1. X as 1, y will be what? 3. This is basically ordered pair is 1 comma 3. If I take ordered pair as 3 comma 1, it should also be there. So take this value y equal to 3 times of 3. I'm taking x as 3, no? 3, 9. So this is not possible, right? It means not symmetric. What about transitive? Let's check a combination. I take 1, 3, 3, 9. Right, they are defined. Y equal to 3x is defined over here, and over here also 3 into 3 is 9 and 3 into 1 is 3. But if I take the combination of 1, 9, is it defined? Y equal to 3 into 1 is 3, not equal to 9. It means this is not possible. Hence, not transitive also. Not transitive also. Please check. Not transitive as well. So given relation is neither of one of them. Okay, let's start. Next one. Clear? 14th one. Okay, R1 R2 are two equivalence relations. Okay, I'm going to take an example and solve this. I can solve it with A, B, B also. Okay, like AB and BA, like that we can solve. But let me do one thing. I'll take a simplest example. For example, I take this relation R1, let's say has, for it to be equivalence, let's say it has AA, it has BB. Okay, A, BB, that's enough. A, BB, and I should have, what is it? AB, and I should have BA. This is the equivalence relation. We all know that R1 is equivalence. Yes. So for R1 and R2 to be both equivalence relation, okay, let's say R2 is only defined with this. R2 should be only defined with this. A, okay, or forget about that also. Forget about that also. I'll take another combination. I'll take this as, let's say R1 and R2 are two equivalence relation on a set. Okay, on the same set, right? On the same set, it has to be, of course, having the same condition, no? Having the same condition. Okay, this will be same like this. So if you take the union, you will have the same things, right? Without repetition. If you take the union, you will have the same result without repetition. Without repetition, that's how you take union. So basically you're going to end up with the same combination. If I take for all of them, okay, I'll take the same combination. If you want, you can take the combination of a set like this, 1, 2 or 3. Okay, make a equivalence relation on this. I can make two type of relation. For example, I can make this 1, 1, 2, 2, 3, 3. This is my, let's say, relation R1, and let's write a relation R2 also. 1, 1, 2, 2, 3, 3. Okay, this is incomplete. Okay, all right, and we can write here 1, 2, 2, 1. This also is an equivalence relation. If you take union of both, what is the answer? Simply R2. Correct, no? Because you won't copy anything, you won't repeat anything. So R1 and R2 union will be, in this case, R2. Now, if R1 and R2 are both equivalence, the union is also coming as equivalence relation only, no? Check. Yes. So even the union will come as equivalence relation. I've taken both the cases of the variables and the numbers to show you that. Question number 15, let's solve now. So that the function fn to n, fx is 2x is 1 1 but not onto. Let's try for 1 1. F of x1 equals to this. Okay, 2 2 cancels. So yes, fx is 1 1. Fx is 1 1. What about onto? Let's try. Y equal to 2x if we have, I get x value as y by 2. Defined on codomain as natural number. I can take y as 3. I can take y as 3. Is 3 by 2 a natural number? It's never going to be equal to a natural number. It means there is some value of y for which there is no pre-image in the domain. Okay. So this number 3 over here, 1, 3, 5, these will be left out. So if you write here 3, 4, 1 will map to what? 2, 2 will map to what? 4, and 3 will be to 6, and so on. So basically some elements of this set will be left out. For that reason, it will be not onto. Not onto, right? So basically into. Not onto. Is it clear? Question number 16 now. Okay. Okay. If f r2 are defined by, all right, so that it is neither 1 1 nor onto. Let's start with the first one. F of x1 equals to f of x2. F of x1 equals to f of x2. So 1 plus x1 square, 1 plus x2 square, 1 and 1 is cancelled. Just explain to this. This will be not 1 1. Okay. Because for one value of x, I'm getting two different values of x2. Okay. But they should have been equal actually. I'm getting two different values. So not possible. Hence fx is not 1 1. Now check. I have y equals to 1 plus x square. What is the range then? What is the range? Range is nothing but 1 to infinity. Can you go below 1? You cannot go. X square can be minimum 0. X square can be minimum 0. If it is 0, I'll get 1. Any other value of x you're going to take will be more than 1. Range is 1 to infinity. What is the codomain you check? Codomain is all real number. Simply, the codomain is not equal to the range. Therefore, the given f is not onto. Not onto, not 1 1. Moving on to question number 17 now. So that the modulus of function f r2r is neither 1 1 nor onto. Approach will be same, okay. Graphical approach will be same. F of x1 equals to f of x2. So mod of x1 equals to mod of x2. So x1 equals to plus minus x2. Okay. So f is not 1 1. And for onto you want to check. For onto method, what is the range? Range is 0 and positive, means basically from all real number remove the negative real numbers. From all real number remove the negative real numbers. I can have 0 also, right? So from all real I've removed the negative real number. That's my range. And what is the codomain? Codomain is given as all real, which implies that they are not equal. So your codomain is not equal to the range. Hence it is going to be what? Not onto function. Not onto function. If you want to use the graphical approach to understand the same thing, let's do that. Check here. This is your modulus function. We are getting two intersections, means not 1 1. Okay. And what about this? This is all left out. Okay. This is left out. Means we have only positive values. So range is only positive or 0. This is left out. These values are left out in the codomain. Left out in codomain. Okay. Hence it will be not onto as well. 17th is done. Question number 18 now. So that the relation R in the set A given by this condition, relation A minus B is even, is an equivalence relation. Okay. So for reflexive, actually I don't need even the elements over here, because if I take reflexive relation, check here, Okay, I have to go like this. ARA, which makes the ordered pair to be A comma A. So if you write over here A minus A, you'll end up with 0, which is even. I can divide by 2, no? Can be divided by 2. Right here. Can be divided by 2. Can be divided by 2. Cool. Okay, next one, which is your symmetric. Symmetric you check now. I'll have to go what? 1 2 2 1. In this case we cannot have 1 2, we can have 1 3 3 1. Okay, so 1 3 3 1, and we have 2 4 is there, of course. 2 4 4 2, 2 4 4 2, and the last combination is 3 5 and 5 3. Also we have 1 5 and 5 1. These combinations are possible. Please check. Symmetric, right? 1 3 3 1, 2 4 2 4 2, 1 minus 3 is minus 2. Again we have 3 minus 1 is 2. If you take modulus, it will be even only, right? This will become 2, this will also become 2. Here also is difference is 2. Here also difference is 4. It means it will be even only. Okay, so this is symmetric. Please check. Okay, basically idea is that if A minus B is even, then of course B minus A will also be even. Will also be even. Okay, that's the idea for symmetric part. Moving on to the last case of transitive. Okay, last case of transitive. So for that you'll have 1 3 5. That's it. 1 2 3 and 3 to 5. 1 3 and 5 in this particular set. Anything else possible? No. 1 3 and 5 only. So for 1 3 difference is 2, 3 5 difference is 2, and 1 5 difference is 4. So 1 3 difference is 2, 3 minus 5 difference is also 2, so both of these are even, and 1 minus 5 difference is 4, also even. So basically what is the case here? Transitive relation as well. Now combination of all the three, if the given relation is reflexive, symmetric as well as transitive, it means it becomes simply equivalence relation. Simply equivalence relation. Clear? Simple question, right? Okay, question number 19 now. Let's move on to 19th. Prove that the greatest integer function is going to be what? Neither on 1 nor on 2. Of course you check. If you check here, what's the domain? Domain will be all real number, no? Here, domain and codomain are all real numbers. So if I take f of 1.5, what is the answer? It's going to be 1. F of 1.8. What's the answer? 1. So basically f of 1.5 is equals to f of 1.8, but 1.5 is not equal to 1.8. For two different values of f, I'm getting the same value of, different values of x, I'm getting the same value in the function. It means the given function f is not, is not 1 1. Is not 1 1. Not injective. Moving on to the range side. Range you check. Range of this function is always an integer. Whatever value you put, you're going to get always integer, which is not equal to the codomain. Hence, f is not onto. Done? Okay? Yes. Next question. Question number 20. F n to n be defined by fn equals to n plus 1 by 2 when n is odd, n by 2 when n is even. For all n belongs to a natural number, then justify this whether a function is bijective or not. Okay. Okay. Let's try. First we're gonna go about your 1 1 part. So let's find f of 1. 1 is odd. I'll use this 1. So 1 plus 1 by 2, which is going to be 2 by 2, hence 1. Let's try f of 2. N is even, we're going to use this. So 2 by 2, again 1. So I'm getting f of 1 equals to f of 2, but 1 is not equal to 2. Therefore, f is not 1 1. F is not 1 1. Okay, and what about onto function? Let's try the range as well. I'll take both the cases individually. N plus 1 by 2. I'll get here 2y equals to n plus 1. So I get n equals to 2y minus 1. Check. For all value of y from where? From the codomain. What is it? For all value of y here, codomain natural number. Check here. 2 into a natural number minus 1. 2 into a natural number minus 1. 2 into 5 minus 1. 10 minus 1 is 9. N will also belong to a natural number set. So means both of these are true. For all value of y from natural number set here, there will be an image in the domain. Okay, so every element in the codomain is mapped. Every element in the codomain is mapped. Same way. Next one. Okay. N equals to 2y. N equals to 2y. Check here. For all values of y from the, again, codomain, any value you put, 2 into y will also be a natural number. So n will also be a natural number. So basically all the elements in the codomain has a image, pre-image in the domain. Okay, so it implies that codomain is equal to range because none of the element in codomain are left out. It's very important statement. I know it feels very silly, but it's gonna help you understand this whole thing very easily. None of the element in the codomain is left out. For that reason, the given codomain and range are equal. Hence, the function is onto. F is onto function. F is onto function. Clear? Okay. So this is the end of your 3 marker. We're gonna move on to the 5 marker now. What is this? 21. Consider f n to y. So domain is all natural number, no problem. Codomain. Codomain is actually this particular relation. Here. So let's write the codomain first. When x is what? X belongs to natural number. So x is 1, y will be 7. First element is 7. 4 into 1 plus 3 is 7. X is 2. So we'll have 4 into 2 is 8 plus 3 is 11. Okay. X is 3. 4 3 is 12 plus 3 is 15. X is 4. 16 plus 3 so 19. And we have again 23 and so on. Right? 7, 11, 15, 19, 23 so on. This is my codomain. This much is clear. Domain, you know, it is natural number. Now we'll move on to proving it invertible and find inverse. First step will be to do what? This. Let's find it. 4x2 plus 3 cancels. Then we'll have 4x1 equals to 4x2 left. 4 cancels. x1 equals to x2. We all know the combination over here. If f of x1 equals to f of x2 and x1 equals to x2, it means the given f is 1 1. The given function is 1 1. Okay. Now moving to onto part. Now for this, you check here. Y equal to 4x plus 3 I have. Y minus 3 equals to 4 of x. From here I get y minus 3 upon 4. Now check carefully. When you put y as 7, you'll get 7 minus 3. How much is that? 4. 4 by 4 is 1. So when y is 7, I'm getting the x value as 1. When y you put 11, 11 minus 3 will be 8. 8 by 4 is 2. Okay. So basically for every element in the codomain, there exists a natural number which is part of your domain. So basically, if you check over here, your codomain becomes equal to the range. Hence, the given function f is onto as well. Now check the last step, finding the inverse of the function. So we have y equal to 4x plus 3, make x subject, so we get y minus 3 by 4 equals to x. Interchange the value of the variable y equal to x minus 3 by 4. This is your inverse. This is your f inverse of x. Check carefully. Question number 21 is done, complete. Next we are going to move on to question number 22. Now another question on the same rational function. X minus 2 upon x minus 3 is the function. We are going to look for 1 1 on 2. Let's try that. First condition is this only. F of x1 equals to f of x2. So x1 minus 2 upon x2 minus 3. Excuse me, my bad, it's wrong. X1 minus 3 and x2 minus 2 upon x2 minus 3. That's all right. F of x1 and f of x2 cross multiply. We get here x1 x2 minus 3x1 minus 2x2 plus 6. The first part, this two cross multiplication. Over here you check. Again you're gonna get x1 x2 minus 2x1 and minus 3x2 plus 6. Okay, check now. X and x2 is cancelled, plus 6 is also cancelled. So what I'm left with is minus 3x1 minus 2x2 equals to minus 2x1 minus 3x2. Just keep the like terms on one side. Like terms on one side. Okay. So I'll get here minus 2x2 plus 3x2. Am I right? Yes. Equals to minus 2x1 plus 3x1. Check here. This is going to be x2. This here going to be x1. Started with this, reaching over here. It means f is 1 1, sir. F is 1 1. Okay. Super. Now we're gonna find what? The range value. What did I tell you about that? Very simple, sir. Start the subject with y, make the subject x. Y equal to x minus 2 upon x minus 3. Cross multiply. I'll get xy minus 3y equal to x minus 2. Put the x terms on one side, y terms on one side, will get xy minus x equals to 3y minus 2. X is common, y minus 1 equals to 3y minus 2. So x equals to 3y minus 2 upon y minus 1. Now from here, find the range. Find the range. Check the range means the restriction on the y. Okay. So basically y can be anything but not 1. Because it's going to be undefined in that case. If you put y as 1, it will become 1 minus 1, which is 0. So y can be anything but 1. So basically my range here will be, check, my range will be y belongs to all real except for 1. Check carefully, this is same as the set B. This is equals to set B. So what I'm getting here, my codomain is equal to the range. So the answer is what? Given f is onto. The given f is onto and 1 1. Okay, so we have the last question now. R1 and R2 are equivalence relation. They're saying that R1 and R2 is intersection will also be equivalence relation. We have to find out that. Okay. All right, and they should be having one more statement here, that they are not disjoint. And R1 and R2 are not disjoint. It means R1 intersection R2 is not equal to null set. Okay, this is a statement given in the question. Okay, it's typing mistake. R1 and R2 are not disjoint means R1 and R2 intersection is not a null set. Okay, is not equal to a null set. Something is common. Okay, so let's say I am going to take common as the ordered pair AB. Let's say AB is the common ordered pair of R1 and R2. So I'm going to include this ordered pair AB in all the relations R1 and R2. Write the relation R1 then. So we'll have AB. It should be what? It should be a equivalence relation. So it should mean that it should have BA. Okay, AB is there means it must have BA also, transitive, and it should have AA and BB others are there, I'm not sure, but this, at least this must be there, because I'm taking, let's say there's only one intersection possible, which is AB. For that case, R1 has to be this, right? Same goes with R2 also. R2 can be other things also, but minimum this has to be there. The minimum this has to be there. So AB, BA has to be there, and of course this has to be there. Even this has to be there, this has to be there. There can be more than this also. There can be CC, AC, BC and CA, all that be there. It's okay, doesn't matter. I'm saying have CC here, BC, CB, AC, CA, all that should be there. Whatever it requires to make R2 equivalence, do that, have it, okay? But now if you take the intersection of R1 and R2, what are you gonna get? You'll get actually the relation like this only, no? AB, BA, AA and BB. So basically whatever is the combination, the intersection will be at least this much. In that case what happens? In that case what happens? Even this will be a equivalence relation. So I have dealt with a question like this using union, okay? This is another very beautiful question, so do solve it. If you want, try another, taking another set 1, 2, 3 and solve like that, okay? Solve like that, because I said no, relation in the set A, define the set A, okay? Define a set A, and for that you write the reflexive relation R1 and R2, so not reflexive, equivalence relation R1 and R2, and continue, okay? This is clear, let's move on. Now last one, as I said already, I'm gonna give you one question as homework, and it's a very good question. Okay, it's a very, very good question. Now one more thing, I will discuss this question in your next session before I start the continuation, okay? So I'll discuss it. I want to know if, but I'll discuss only when if you have solved it. If you won't solve, if you won't give me the answer, I'll not discuss this, okay? So please make sure that you have solved this question. This is a 5 marker. This is a 5 marker. Solve this question and let me know how you got it. Next one. So next what we have is the last important information from my side, important topics. So basically what type of questions are expected. So 3 categories are there, 1, 3 and 5 mark. In 1 mark you can question can be coming on definition based, definition of the basics of relations, whether it is reflexive, whether it is symmetric transitive or universal relation or null set and all those things, okay? So that can be asked in definition side for 1 mark. For 3 marker, there can be a question on the reflexive basically equivalence relation. There can be a question, even 1 marker can be a question on number of relations, number of bijections, and those questions can also be asked, okay? 2 categories. Number of, in the 3 marker we can have equivalence relation, or we can have your 1, 1 onto function. Both can be asked. So it's given here. Please check. And number 5 will be of course on the inverse of the function, most likely, or they can sometime ask you relation to be equivalence or like that, okay? What I chose the example, no, R1 R2 example that can be asked. And very important thing will be MCQ. From here you cannot lose marks. MCQ cannot be lost marks in it. Very simple. Reason is you have learned a chapter, right? MCQ is based upon the very basics concept of the chapter. It means MCQ has to be scored well in. So 20 marks, 1 marker are there, you have to score 18, 17 plus in the 20 marks minimum. If you can score 20, very good, but 18 plus 18, 17 you have to score in all the MCQ examination of mathematics, okay, for your boards thing. So I hope this is clear. So this concludes our session today for your Brahmastra 2.0 mathematics. Do join in for more such sessions. As I said, I'll discuss your whole concept, whole revision, all the important topics. I'll give you everything that you need to do to get this top score in the Brahmastra, so in the PU2 examination, in the boards examination. So if you're watching my video for the first time, do not forget to subscribe right now to our channel Deeksha Karnataka, because we are bringing in more and more such content, more and more such lecture sessions which will help you achieve your dream marks in maths, physics, chemistry, biology and so on, okay? So do make sure that you are subscribing the channel and coming every time to get to know what are the classes and all those things. And how can you do that? Simply join the WhatsApp channel which is given. The link will be given in the description. Go ahead, join it, so that you get to know the schedule. We release every week schedule for Brahmastra also. So this week's schedule is already given to all of you who have joined the WhatsApp channel. Who have not joined yet, join right now. Schedule is given. The classes are going as per schedule only. So do join in to make the most of it, so that you don't miss any classes, because we don't have time to have a backlog right now. Okay, it's time to get creative, get hardworking, and you have to get the results done. And that can only be done if you are consistent, if you are able to follow all the things on time. That can be easily done using the WhatsApp channel we have. We keep putting information regarding the classes in that, also the PDFs versions. So whatever it is, do make sure that you have joined the channel and subscribe to us right away. I'm going to see you again in another session of Brahmastra. Till then, take care. Bye bye.